In the last clip, we solved the system shown here to find the solution vector y, which formed the general solution to this equation. We went through the details and we found that we have a solution with eigenvalue 8 and eigenvector 1, 1, eigenvalue 2, eigenvector negative 5, 1. With distinct eigenvalues, we know that our solutions, our eigenvectors, are linearly independent, and that the set that we get by applying each eigenpair to the form e to the lambda tx is a fundamental set, so that our general solution is of this form, and that equals this, which is probably more or less readable. That general solution, of course, consists of y equals y1, y2 equals this. If we multiply this out and add them up, we get, again, and I'll write it out a little more clearly, so that we have this solution to our system. And this is our general solution. Any solution has to be of this form with some pair of constants, C1 and C2. Now, our original equation had an initial condition. Y of 0 should equal negative 2, 3. So that y of 0, which is equal to what we get when we plug in 0 for this equation, and conveniently, if we plug in 0 into any of these, the exponential becomes e to the 0, and that's just 1, so that we just get C1 minus 5C2, C1, C2, and that equals our y of 0, which, if I remember correctly, was 2, negative 3. Let me just check that to make sure. Nope, it's negative 2 plus 3. Okay, so our system can be written as a system of equations. There are many ways to do this. We can simply invert this matrix and multiply by this, but I'll write down the system very explicitly because this is the first method you used for solving a system of equations. So we have this. If we add, or let's say if we multiply the first equation by negative 1 and add it to the second, C1 is going to go away. We're going to get 6 C2 equals 5, so that C2 equals 5/6, and then C1 plus C3, well, that's going to be C1 plus C2, not C3. Reading the 3 over here. Plugging in this value of C2 into the second equation, we get this. 3 is 18/6, and you subtract 5/6. C1 equals 13/6. 18 minus 5 being 13. Wanted to check that before I wrote it. So our solution with the initial conditions is y1 equals what we get over here with C1 equal 5/6 and C2 equal 5/6 and C1 equals 13/6. So it's 13/6 e to the 8t minus 5 times C2. So that's going to be 5 times 5/6. That's going to be 25/6 e to the 2t. And we're going to get y2, and it's going to get a little crowded here, unfortunately. But our y2 solution is going to be c1 e to the 8t plus c2 e to the t, and that's just going to be 13/6 e to the 2t plus 5/6, and that's 13/6 e to the 8t e to the 2t, and this is our specific solution for the initial condition. You can't read that, but this is our specific solution for the initial condition. To summarize, our original equations with these initial conditions using y vector equal to y1, y2 column vector give us the equation y prime equals 3, 5, 1, 7. That's our A matrix multiplied by y. That translates in terms of this y vector to y1 prime, y2 prime. That's our y vector prime equals the same matrix times our y vector, which is just the y1, y2 vector. Assuming that y equals e to the lambda t times x1, x2, and following the process, we get eigenpairs 8, 1, 1, 2, negative 5, 1. You have eigenvalue 8, eigenvalue 2, eigenvector 1, 1, eigenvector negative 5, 1. So that's an eigenvalue. And this is an eigenvector. This is also an eigenvalue and an eigenvector. These eigenpairs lead us immediately to the fundamental set. This fundamental set, an arbitrary linear combination of the vectors in the fundamental set c1 times this plus c2 times this. If we write it out, and we did, we find that y1 is going to equal c1 e to the 8t minus 5c2 e to the 2t, y2 c1 e to the 8t plus c2 e to the 2t. Our initial conditions, y1 of 0 equals negative 2, y2 of 0 equals 3, we obtained using the matrix, but we brought it down to a system of linear equations in C1 and C2, and we could do the same here, plug in 0 and set the result equal to negative 2, plug in 0 here for t, set the result equal to 3. We'd get the same equations, same values. C1 is 13/6, C2 is 5/6. Let's just bring this full circle and write the general solution. Okay, the general solution is then I'm sorry, I said write the general solution. We've already done that. Write the specific solution and verify that it satisfies the equations with the initial conditions. It's easy to verify that the equation satisfies the initial conditions. If y1 prime I'm sorry, I'm ahead of myself. Okay. We're not doing the specific solution with the initial conditions. We're just verifying the general solution and verifying that any solution of this form with y1 and y2, these forms, does satisfy the equation. And it's fairly easy to do that. y1 prime, we just take the derivative here, and it's very clear. We get an 8 here, we get a 2 here. It's going to give us y1 prime is 8c1 e to the 8t minus 10c2 e to the 2t, and you can verify that as easily as anyone. And y2 prime, we're going to get the 8 here, we're going to get the 2 here, and I haven't written that down, but that's what we would get. We get 8c1 e to the 8t plus 2c2 e to the 2t. So y1 prime is this, and that should equal 3y1 plus 5y2. 3y1 plus 5y2 is 3 times this, just written it out, and 5y2 is just 5 times this. I've written that out. And what does that equal? Well, you see in front of the 8t, we've got a 3c1 and a 5c1. So that gives us 8c1 e to the 8t. And then we have a minus 5c2 and have a problem here. Let me stop a second. Okay, I just missed the fact that this negative 5 is multiplied by 3, giving us negative 15c2 e to the 2t, and a 5c2 e to the 2t, giving us a negative 10 c2 e to the 2t. We see that this agrees with this, so that y1 prime is equal to 3y1 plus 5y2. And we might as well finish this up if we have room. Y2 prime, as we said earlier, is 8c1 e to the 8t plus 2c2 e to the 2t. And that should equal y1 plus 7y2. Now I'm not going to write it all out here. Y1 is just this, and 7 times y2. Well, if we do y1 plus 7y2, we get c1 plus 7c1, which is 8c1 e to the 8t. And that matches what we got here. And then we have negative 5c2, that's our y1, it's just going to give us a negative 5c2. 7y2 is going to give us plus 7c2, so that's going to be plus 2c2 e to the 2t. And this are the same, and that checks.